Good afternoon. Few days back, one chapter was started. The name of the chapter was Gravitation. It's a very fast chapter. There you will find one topic, that is apparent weight and weightlessness. Apparent weight and weightlessness. So I am talking about apparent weight. I am talking about weightlessness. So what is true weight then? True weight can be measured only when you are, or the object of which you are going to measure the weight, if that object has no relative motion with respect to earth. If that object has no relative motion with respect to earth, then only you will be able to measure the true weight of that object. You can use spring balance to measure the weight. You can use weighing machine. Today, almost in every shop, weighing machines are used to measure the weights of the substances. You might have seen weighing machine. Digital displays are there. So whenever you are putting one object on the platform of the weighing machine, the display shows the weight of the object. Okay. Actually, it shows the mass. Say you have put 10 kg of something, say 10 kg potatoes. You have put on the platform of the weighing machine. So in the display, you will see that it is showing 10.00. Okay, that means it is 10 kg. So weight is how much? You know, weight means 10 multiplied by 9.81 meter per second square. So that is the weight, you know it. Displays show mass, not the weight. But by using that machine, you can measure the weight. By using spring balance also, you can measure the weight. So what happens whenever you are putting something on the platform of the weighing machine, the weight of the object acts in the vertically downward direction. And the normal contact force acts in the upward direction. The substance or the object is in static condition. It is in static equilibrium condition. So when it is in static equilibrium condition, the weight on that object, okay, of which you are going to measure the weight, on that object, the weight of that object is acting in the vertically downward direction, and the normal reaction on that object, which is exerted by the platform or the contact surface on that object, and both are same. If weight is W, which is vertically downward, direction is vertically downward, and normal reaction N, that is upward. Here in this case, in static equilibrium condition, this W is equal to N, or N is equal to W, both are same. So normal reaction is equal to W. So whatever is shown by the display of the weighing machine, it is the normal reaction. So by observing the normal reaction, you say that weight of this object is this much. Okay. Now you take that weighing machine inside an elevator. Elevator means a lift. Okay. You take that weighing machine inside that elevator, and if you stand on the platform on the weighing machine, and suppose the elevator is in static condition, it is not moving. It is neither going upward nor going downward. Okay, it is in a static condition. And suppose your weight is 80 kg, means mass is 80 kg, weight is 80 into 9.81. Okay, Newton. That much of Newton is your weight. Your mass is 80 kg. So when the elevator is in a static condition, the display of the weighing machine will show 80, means 80 kg. Weight is how much? 80 kg weight, or 80 into 9.81 Newton. It will show that much. Now suppose the weighing machine, the elevator goes in the downward direction. You will feel heavy. If you have already used elevator, then you know this thing. You will feel heavy. What happens here when the lift goes in the downward direction? What happens? If you draw the free body diagram of that man, means free body diagram of yourself. If I draw, so your weight, your mass is m, so weight is how much? It is mg. It will be acting in the downward direction. Okay? And normal reaction exerted by the platform of the weighing machine will be acting in the upward direction. Say that normal reaction is N, capital N. N for normal. Now, what I said, the elevator is going in the downward direction with some acceleration. Say the acceleration is A, small a, acceleration. So since the elevator is going in the downward direction with an acceleration, and you are inside the elevator, and between your body and the elevator there is no relative motion. With respect to the elevator, you are in static condition. That means the acceleration of the elevator and acceleration of your body are same. Right? Acceleration of the elevator and acceleration of your body are same. So, if I make force analysis of your body, what will happen? That means here, since acceleration in the downward direction is A, because elevator is moving in the downward direction with an acceleration A, so net force acting on your body, it is equal to ma. M is mass of your body and A is the acceleration. So net force acting in the downward direction is equal to ma. Where from this net force is coming? It is coming from that normal reaction and your body weight. So here, your body weight must be greater than the normal reaction. Then only this ma is possible. This plus ma is possible only when your body weight is more than the normal reaction. That means your body weight is how much? It is mg. Normal reaction is how much? It is n. So mg minus n must be equal to ma. Then only this is possible. Your downward movement of your body with an acceleration a is possible only when mg minus n is equal to ma. So n is how much? N is how much? mg minus n. Sorry, one thing, I have committed one mistake. When the elevator is going in the downward direction, you will not feel heavy. Your apparent weight will be less than your body weight. It is just opposite to heavy. You will feel lighter in weight. Okay? That mistake I have committed just in the beginning of this video lecture. Okay? When you are going in the downward direction with an acceleration, you will feel lighter, not heavier. Okay? Sorry for the mistake. Extremely sorry. So, what I was saying? Yes, mg in the downward direction, n in the upward direction. So mg minus n is equal to ma. So n is equal to how much? It is mg minus n. Means m into g minus a. N is equal to m into g minus a. So g minus a, there is no doubt g minus a is less than g. G minus a is less than g. That means n is equal to less than mg. N means normal reaction is less than mg. mg is your body weight. So normal reaction will be less than mg. So mass will be accordingly, mass will be how much? N by g, that will be the mass, and that thing will be shown by the display of the weighing machine, and it will be obviously less than 80 kg. Okay? And when the elevator is going in the upward direction with an acceleration a, then obviously the normal reaction will be more than your body weight. Then only this is possible. So in that case, how will you write the required equation? In that case, n in the upward direction, mg in the downward direction. So n minus mg is the net force acting on your body for which you are moving with an acceleration a in the upward direction. Right? So n minus mg is equal to ma. So n is how much? It is mg plus ma, means m into g plus a. Obviously, m into g plus a is more than mg. Means normal reaction is more than mg. So what will be the corresponding mass? N by g. That is the corresponding mass. So the weighing machine will show more than 80 in that case. You can do this experiment. Just you have to hire from somewhere and a weighing machine and nothing else. Very easy experiment and very interesting, of course. Okay? So only two cases I have considered here. So these are apparent weight. These are apparent weight. Okay? This n in both the cases are not equal to your body weight. When the lift is moving either in the upward direction with an acceleration or in the downward direction with an acceleration. In both the cases, n means normal reaction are not equal to your actual body weight. So these are apparent weights. Okay? Now suppose the third case. Just consider the third case. Say you consider free falling of the lift. What is the meaning of free falling of the lift? Free falling of the lift or the elevator. Free falling of the elevator, that means the elevator is going in the downward direction with an acceleration equal to the acceleration due to gravity. That is g. Small g. Means 9.81 meter per second square. That will be called free falling. Okay? We know that acceleration due to gravity is g, small g. If anybody falls with that acceleration in the downward direction, then we will say that it is a case of free falling. So we are now considering free falling of the elevator. So what is the acceleration? G, mg in the downward direction, n in the upward direction. Your body weight is how much? It is mg, means true weight, mg. It is in the downward direction. So what will be the equation? mg means your body weight minus n means normal reaction. It is equal to mg. Because you are moving with an acceleration g in the downward direction. So mg minus n is equal to mg. How much is the mg? mg minus n is equal to mg. n is 0. So what will be shown by the display of the weighing machine? A big 0. It will show 0. Because normal reaction is 0. Whatever is shown by the weighing machine is the normal reaction exerted by the platform on the object which is kept on the platform. Okay? Normal reaction is shown by the display of the weighing machine. So since normal reaction is 0, so what is the mass? Normal reaction by g. So 0 by g is equal to 0. So the weighing machine will register 0. Okay. And in case of space stations, you know, space station, they revolve around the earth in an orbit. Okay. And you have heard the term weightlessness means no weight. Everything is floating inside the space station. Everything is floating. Everything floats inside the space station. Why? Why everything floats there? Because when space station moves around the Earth in an orbit, what happens there? Force of attraction of Earth, gravitational attraction, and force of attraction, what is the function of that? That provides the necessary centripetal force. Whenever the space station is moving around the Earth, centripetal force is required. That centripetal force is equal to the attraction of the Earth, gravitational attraction. So what happens there inside the space station? If you consider any object inside the space station, okay, so on that object, gravitational pull is acting, right? And that is equal to centrifugal force. Since it is moving in a circle, so centrifugal force will be acting there. So that centrifugal force is equal to this gravitational attraction. They are balancing each other. So what about the normal reaction? Normal reaction will be there, 0. They are equal to each other. Centrifugal force and the gravitational pull, they are equal to each other. So normal reaction will be automatically 0. Since normal reaction is 0, so there is no weight of any substance, of any object inside the space station. So if you use one weighing machine inside the space station, there also the weighing machine will register 0 for any object kept on the platform of the weighing machine. That is also apparent. Okay. So since on any object there is no force acting, so that object will float inside the space station. And this condition is called weightlessness. Same thing for free falling also. The condition is weightlessness. When the elevator is freely falling under the action of gravity, when the elevator is freely falling under the action of gravity, this is also a case of weightlessness. Whenever a stone is thrown, not thrown, it is just left. Suppose a stone is left from the top of a building with 0 initial velocity, it is just left. Then also it is a case of free falling. It is a case of free falling, and this is also a case of weightlessness. If you jump from the top of a building, during the course of motion of your body, you will feel weightlessness. Means you will feel 0 weight. Okay. So this was all about apparent weight and weightlessness. Okay. Next topic. A different topic will be discussed for the same chapter. Chapter is gravitation. Thank you.